today's video, I'm going to be teaching you how to design a staircase. So, the architectural design of a staircase, that's what we are going to be doing today. And the purpose of this video is because I've seen a lot of staircases that are too steep, So, in this video, we are going to be talking about how to design the architectural design of a staircase, how to know the number of the riser and the sufficient thread you need for a staircase design. So the content of this video is why the video, the parameters in designing an efficient staircase, then the design of the staircase. We are going to do a design of the staircase probably in AutoCAD. So I'm going to draw it and you are going to see how to calculate the number of riser and thread needed in a staircase. So let's start. Why the video? So just like I've said it in the introductory part, that the reason I'm doing this video is because of some steep staircase that I've seen. Look at this staircase now. Look at how steep it is. So going and the main purpose of the staircase is to take someone or property or a material from one floor to another, probably from the ground floor to the first floor, or from the higher floor to the lower floor. That's the function of the staircase. Meanwhile, however, when we are designing staircase, like, you need to consider something. The staircase must not be a thing that when you are climbing, you are feeling too stressful or you are feeling discouraged to climb. In the design of staircase, there are some things you must consider that you make the staircase very comfortable for the people that want to use it. So I've seen a lot, and the failure we do have in construction most of the time is steep staircase. Is always too steep the way people construct it. Now, let me show you more example of steep staircase. Okay, look at this now. Have you seen this? It's too steep. Too steep. At least this is even better, but look at this. It's too steep. So climbing this kind of staircase is somehow difficult in climbing it. Let's take a look at the next slide. Exactly. Look at something like this. So this one is too steep. Coming down from the highest point here to this down to this lower point there, someone might even slip off and fell off the staircase. So I decided to put this video. Look at this staircase. Look at how gentle it is. Gentle riser and gentle riser. I mean, look at it's very easy to climb and very easy. Although there will be some stress while climbing the staircase, you feel some stress, but at least it should be a minimal stress. It should be a minimal. Look at this. It's too high. Just take a look at the video. Look at this one. The picture rather. This one is too steep. So in this video, I'm going to teach you how to do the riser and the thread to make it very easy. Now let's go to the parameter we need in designing staircase. Parameter in designing an efficient staircase. So I'll list seven major parameters, and I'm going to be showing you the diagram of how they look like. So number one parameter in designing an efficient staircase is the height of riser. So the height of the riser. So the height of the riser, these are the riser. These are the riser. The one this one, the rise, the one that is labeled rise in this diagram is referred to as the riser. And the riser have a minimum dimension, which is 150 mm. That is 6 inch. The riser must not be more than 150 mm and maximum of 180 mm. It must not be lesser than 150 mm, rather, that's 6 inch, and must not be greater than 180 mm. I've seen some riser that is greater than 180 mm, that is 200, 190. So the disadvantage is when the riser is high, you are going to have a lot of difficulties in climbing the staircase. Look at these ones now. The risers are high. You understand? You are going to have issues in climbing the staircase. If a riser is even lower, most of the time that I've climbed a riser with a staircase with lower riser, most of the people always fell off it because we are used to the fact that the 150 is to be full. The 150 is the minimum I can recommend for anybody. I've seen a riser of 4 inch. You get 4 inch. That is 100 mm, but it is too small to the extent that you can hit yourself, or even to take a step at a time will be somehow difficult. So it's better you take 2 steps at a time because the riser is too small. So the minimum riser should be between 150 to 180 mm. Anything beyond this might injure the user. So the next one is the width of thread. width of thread. Now this is the thread, the place you people place their leg, the place you place your leg on the staircase is referred to as the thread. So, and here the minimum dimension of the thread should be 250 mm. Why is it 250 mm? An average woman feet, if you check an average like me now, my feet is 270 mm. So imagine I have 270 feet and I'm placing it on something that is 250. Is that not somehow comfortable? Yes, it is comfortable. So but and I was saying an average human feet is between 250, 260, 270. You understand? So if you are having a thread that is, imagine it, the thread is where you place your leg, and you are having a thread that is below your feet, that is below, that is smaller than your feet, it will be difficult to climb, because it will be easy to fall off the stair, because you are not, your leg is not well placed on the thread. So the minimum dimension of thread is 250 mm. You can have from 250 mm, you can have 300, 400, 500, depending on the space you have. So these are the thread. So this thread now is about 1 meter, from what I'm saying, 800 to 1 meter. So the minimum, you should know that the minimum width of the thread is 250 and above, 50 and above. Now, another parameter is the width of landing. The minimum width of landing is 900. Now, the landing is the area where people rest. Probably before you climb the stair, the space you have there is the landing. When you get to the halfway of the stair, probably after 9 or 10 risers, the halfway is also regarded to as landing. People call it half landing. This area here, and at the top of the stair, also at the top after the last riser, you have another landing. So about 3 landings on stairs. Sometimes you have more than that, depending on the width of the landing, depending on how long the staircase is further. So the minimum space of landing, the minimum dimension of landing should be 900 mm. Now the landing is designed to accommodate people. Probably you have come to this stair, or when you get here, you need to take a rest because you stressed yourself, you expended some energy here, so you need to take some rest before you continue. So the landing is regarded as a resting place. Okay, I think this is one of the things I saw before coming up with this video. Look at this. Now I was saying the minimum dimension of landing should be 900. Now imagine this. The door is always 900 mm, the width of the door. Now look at what they've done here. The space they left here, this size is 600 mm. Let's say plus this 10 mm. This, let's say this space, the space they left for landing is just 700 mm. So because they couldn't take the door, so they now need to chamfer the riser and the thread so it can take the stairs. See, that one is already a failure. So the minimum landing you must have should be 900. You can have 900, you can have 1000, in millimeters and so on. But the minimum you should have is 900. So that is that. The number 4 parameters in designing an efficient staircase is the length or width of thread or riser. That is, you can even call it the width of the flight, the width of flight. So this is the first flight and this is the second flight. When you climb the staircase and you get to a landing, that's the first flight. From the landing again to another landing is the second flight. That's how we call it. You understand? So the minimum width of the landing should be 900 mm. This 900 mm so that it can accommodate 2 people. So in everything we do in construction, there is always a factor to it. So it is designed to accommodate 2 people. You understand? So but if a fat person is coming, you need to wait probably on the landing for the fat person to go, but it is designed to accommodate 2 people side by side. So the minimum width of flight will be 900. So you can have more than 900. That is this flight here. You can have more than 900, but the minimum should be 900 for an efficient design. Let's go to another parameter. The next parameter is length of landing. Now, this length of landing can be regarded as the length of the 2 flights together. So, I said the minimum for this is 900, the minimum for this is 900, making 1/8. Then you have a space at the middle, space at the middle of the 2 flights. So let's say it is 100 mm. So when you add it together, you have 1.9. Although it might be more, it can be greater than that. That's why I said minimum 1.9. So you can have 2,000, 2.1. Most of the time we have 2.1. 2.1, you have 2.2, 2.3, depending on the space provided. If it is for commercial use, the width of the flight is always more than 900. Probably when you get to pedestrian bridge rather, or in a commercial place, the width of the flight is always more than the width of the flight here is always more than 900, so that it can accommodate more people. So that is that about that. The sixth parameter is the overall height of stair or total rise. So from one floor to the from the top of one floor to the top of the next floor is regarded to as the total rise. Top of this a floor, this is another floor. So from the top of this floor, this concrete casting or probably the tiling, to the top of the next tile or the next floor is what is regarded to as total rise. So it is always 3.15 meter, that is 3,150 millimeter, because that's what most people usually do. Although it can be greater than that, some are even smaller than that. So but the one that is usually common is 3,150. You can have 3,400, 3,500, 4,000, 5,000, depending. But irrespective of what you have, in this video I'm still going to be teaching you how to design, and you are going to use all the parameters I've just mentioned, that we are going to use it and come up with a suitable and efficient staircase that it won't even stress you while you are climbing. So the seventh parameter is the horizontal length of flight. So this is the length from the first riser to the last riser is what we regard as the total from. So those are the parameters you need in designing a staircase. So let me go back and take it again. So the first parameter I said height of riser. The second one I said width of thread. The third one I said is the width of landing, which is the minimum of 900, and the fourth one I said it is length of thread, that you can say the width of the flight, you can regard that as the width of the flight, which is a minimum of 900 mm. The fifth one is length of landing, which I said is a minimum of 1.9. And the sixth one is overall height. This one varies, it varies. So most at times it is 3,150, 3,200, 4,000, 5,000. You can even have below 3,150. So and this is the total run from the first riser to the last riser. That is the total run. Now let's go to the design of a staircase. Then I'm showing you the parameter and the reason why I'm doing this video. So now let's go to the design. I copied this from an architectural design. So the architect provided into in dimension of 4,630 in millimeter, and the width to be 2,100 millimeter. So we are going to be using this and come up with how the architect came up with these lines. So in construction, the architect don't just come up with this line and say do anything you like. There is a factor for it. I'm going to show you the way we are going to calculate the riser and the thread and have a efficient staircase. Understand? So we need to consider the total rise, also the headroom of the building. So let's look at the headroom of the building. Okay, what is it? So the rise is 3,150 mm. 3,150 mm. So let's go to the calculation and do some things. So, but before then, I can put this in AutoCAD format. Then we'll come back to the design. I already have some things here, but let's draw out some things first. Okay, let's go this way. Let's start from here. So formulas, there are some formula we use in design of staircase. So to get the number of riser you need, it is the total rise divided by the assumed height of riser. Assume, no, I said total rise. Total rise of this building we have now is 3,150, just like I showed you here. Just like I showed you here. Let me zoom in. So just like I showed 3,150. So 3150 is the total rise of this building now. Now assume height of riser divided by the assumed height. So whenever you are assuming something, you make sure you start from 150 mm to 180 mm, because I've said the convenient riser is between 150 mm to 180 mm. Now the number of thread is the total run. Total run, that's when you remove your landing, the remaining space that the thread is going to take when you remove your landing is the total run. I mean something like this: total run, when you remove your landing, this is the landing, this part is the landing, the area the thread is going to take is the total run. Hope you get it now. So total run divided by the assumed length of thread is, these are the formulas we are going to be using. Now from the drawing, we have the total height to be 3150, just like I showed you, and we have the total run to be, okay, just like I just explained now, length provided minus a landing minus the second landing. You understand? So let me take you to AutoCAD and let's start our design from there. So I said the architect, so from what the architect gave us, we have 46302100. Now let's draw something out for that. Let me select my triangle. So I can have 4630,2100. These are the inner dimension the architect give us, right? So I can, from here I can have my my flight. So this is 2100. So I can look for the half of this. Half of 2100 is 1050, right? So let me offset 1050, enter. I can offset this. Okay, I still need to explode this. Okay, let me explode this. Let me first, okay, let me form my work first. 230. Let me form my work. So I have a wall here. Let's assume a wall of 230 now. Let's explode everything. Yes. Okay. Okay, now let me offset and get the, and split my flight. So we just have an open space now. So the first thing I'm going to do is to split this open space into two flight, because from the architectural design you can see we have two flights, right? So I can pick my offset, then 1050, enter. I have this here, then I now offset to 50. We give it the space in the middle. Can offset this one to 50 as well. We give it the space in the middle, right? Then I can now get rid of this. That's it, right? Okay, let me form the door opening. So let me just extend this. I extend this so I can copy, I can offset this by 900 to form the door. Yes. Then let me print this out. Right. Print this out. Print this out. So we have an opening. So landing, I said my minimum land. From the architecture you can see that there's a landing, but the architect didn't give us the space for the landing. There's a landing here also, but the architect didn't give us the space for landing. So we are going to assume our own. I said the minimum landing should be 300, should be 900 mm, right? That's the minimum landing. So let's say we want to have, let's say we have 900 here, and we have 900 here. Let's just take that for now, right? Let's use the minimum. So I can offset there, and now offset 900. Okay, 900, offset 900, offset 900, and let me extend this. Okay, then I can trim this out, trim this part, trim this part. So I have my landing here, and I have my landing. So this is the first flight, and this is the second flight. So we are forming something gradually, right? Yes, we are forming something gradually. So let me check. What's the space left? What's the space left? So I said it is first is 30, right? First is 30. First is 30 minus, we have 900 plus 900, that is 18, right? 18. So what do we have left? We have 2830. 2830. So the space from here to here is 2830. Okay, I have it here. 2830 mm. So I have 2830 mm left for which is the total run. And I said the number of thread is total run divided by the assumed number of thread. And the total rise is 315. You don't have to subtract anything because okay, I'm here already. The reason why we don't have to subtract anything is this. The landing is starting, the staircase is starting from this floor and is ending in the next. It is the last riser flush with the landing of the next floor, so we don't need to subtract anything from that. So number of riser. So my number of riser will be 3150 from the formula here, divided by, now what should we assume as the height of riser? I'm starting from the minimum, so let me start from the minimum, 150, right? 150. So I have 3150 divided by 150. Now let's use our calculator. 3150 divide 150 equals, so I have 21. I have 21. So 21. So the number of riser in this stair is 21. All right, is 21. And number of thread, no, I have 2830 as the total run. So let me assume a thread. Let me assume, okay, let me teach you something. Number of riser, the number of riser is 21. Now the number of riser is always more than the number of thread. So if you have, at the beginning of a stay you have a landing, at the end you have another landing. If you have two landings and your riser is 21, then your thread will be 20. If you have three landings, yes, you have a landing from the starting point, you have a landing in the at the middle of the two flights, and you have another landing at the end, then your number of thread will reduce to 19. How do I know this? I will show you. Okay, let me go back a little bit. Let me go back a little bit. I'm going to get this. Okay, you might not be able to get it from here. Now I can show you from this. Now look at this place now. I just want you to see the practical then before we now start designing. You know, this is, we have a landing, this is the landing here, and this is another landing. So count how many number of riser we have here. 1, 2, 3, right? Before we have another landing. So how many thread do we have? One. This is not a thread, it's a landing. 1, 2 thread. But if you are having a landing in between, so landing is different from thread. You don't regard landing to as thread or as a bigger thread, no. So if just know it that way, that's the way I've explained it. If you have, so here we are having a landing in the middle, so meaning our number of thread will be 19. No, let me now assume, okay, from here, okay, I'm here. Now the length of this is 2820, right? And this one have another length. This is 2820, this is also 2820, but I'm combining the two together. Now this is 2820. So where is it now? Okay, I have 2820. Now let me say on the first flight I want to have I know I want 19, so let me say I want 10 thread in the first space. That's in the first space from here to here. I want 10 thread, and here I want okay, let me say here I want 9, and here I want 10, right? But I know I want 19 in total. So I want 9 and I want 10. So 2830 divided by 9, that would be divided by 9. Now 28 30 divided by 9. So I'm going to have 3141. 3141, like 9. I'm going to have 314. So it means my thread is 314. For the first flight, this is the first flight. And let me copy it and do for the second flight. Okay, let me put it side by side. This one will be 10. So this one is 9, and I want this one to be 10. So 2, 8. Now I have 21 risers, but at the first flight I have 9 risers, 9 thread, and the second I have 10 thread, right? So I can go back to my AutoCAD after coming up with this. I know the thread is 314, right? It's 314. So I can take this, I can offset, right? I know I'm having 9 here, offset 314, enter. I have the thread, the first thread, the second thread, the fourth thread, okay, the third thread, 4, 5, this 6, this 7, this 8, and this is 9. You see, the last one flush with this. And so I can start from this again. We have 9 thread here, and we can start here again. We are going to have the same thing, right? We are going to have the same. Then you will add 1 to the top. No, this plan is for the ground floor. Then I can just add this. I can extend this. So if you are looking at it that this riser now is now, this landing is now shorter. No, this is from the ground floor. We don't know what is in the first floor if you look at it very well. So probably in the first floor, this wall might not exist. Then you can maneuver your way and this landing might be bigger on the first floor. But here you have 900. Here you have 900. So in case, even if this wall is there on the first floor, so you can just bring your riser and put it there. You can just bring this thread and put it there, or have 10 here and 9 here. And that's how to design a simple staircase. That's how to design it. So that's it. So that's how to design. If you look at what the architect did here, so the architect decided to have 10 here and 9 here. So our own indicates that this one will be 9 and this will be 10. That's how to design. That's a simple way to design a stair. It's the simplest way to design a stair. So I can even decide to use 160 instead of this 150. Once this 150 and 314 works, it is perfect. I said the minimum thread should be 250 and we are having 314. So it shows this is even more than 150. 314 is more than 1, which is sufficient. So that's how to design a stair. It's very easy. You can decide to use 160, 170, but once I use 150 and my once it passed, and this passed more than 250, once my thread is more than 250 mm and my riser is between 150 to 170, I don't even design from 180 riser. If it is between 150 to 175 or 170, I'm okay. So this is how to go about how to design staircase. So I hope you learned from this video. Thank you for watching this video. Thank you for staying here. You can click on the notification button if you find interest in this video. If this video really help you, you'll be the first to be notified whenever I upload any other useful video. Thanks for watching.